So in 1995, okay, I was on a plane uh, going from Texas to Bowling Green, okay, North Carolina. And I was on the plane and I started to think about what is going on in the field of neuroscience. And what was going on was that there were many meetings, and the meetings were all separated. There was a dopamine meeting, there was a serotonin meeting, there was an endorphin meeting, okay? There was meetings all separated, okay? There was a depression meeting, there was an anxiety meeting. So I said, you know, the brain is not carved out the way the DSM-5 carves it out. It don't work like that, okay? So there's got to be an umbrella terminology that covers the entire area of mental health, okay? And if there is something wrong, okay, then that would lead to the various behaviors, okay? Now, so I was thinking on the plane, and I said, well, I understand. Maybe we should call it reward, okay? And I said, well, okay, reward. Well, is it too much reward, too little reward? Is there a problem in the reward system, high or low? Okay. And then I said, you know what? It's a dysregulation. Okay. And then I said, but reward dysregulation, it's not catchy. We need something a little more catchy. And then I said, it's really potentially either way, it's a deficiency because it's not working right. Okay. So it don't matter if it's high or low, it's still a deficiency. Okay. So I said, reward deficiency. Then I said, oh, I got it. What about AIDS? Autoimmune deficiency syndrome. And that's how I got it, reward deficiency syndrome. That's the reason why I came up with the name to suggest that the DSM-5 is just a way to look at symptoms, but it's not the way the brain is carved out. And my idea is that reward deficiency syndrome is all mental illness. That's how I came up with it. Functional neurology. Okay. And when what happened was when I came up with it, I sent the idea to the American Scientist, which is a magazine that's run by Sigma Psi, the honorary research society. Okay. And they loved it. And then in 1996, on April 18th, they published a beautiful article on reward deficiency syndrome. Okay. And I could get you that link after we talk so you can see that article. Okay. And that's what opened up the idea of reward deficiency syndrome, which was in 1996. But I coined it, I thought about it in 1995. That's how I came up with it. Okay. It goes back a little bit to the idea that in terms of spirituality, and that's very broad, okay? So it doesn't mean that you have to go to, an institution like a church or a synagogue or a Buddhist temple, okay? You could do it from your brain. And you could think about the fact that, maybe there's something more, okay, to the existence of life than we know it, whether it's God or higher power or something that we don't know, okay? But the generality is that in the world of neuroscience and the world, let's say, of just taking mental illness, okay, or let's say addiction. Let's use addiction, okay, as a subtype of reward deficiency syndrome or a subtype of mental illness. The idea is this, that when people have an inner feeling that gives them some kind of hope for life while they're alive. And then, of course, potentially when they're not alive, which I don't really subscribe to because, as being a neuroscientist, it's difficult for me to understand what could happen after life. It's difficult, okay? But at least in terms of the daily life that people have, the fact that they could have an inner feeling and have hope that something that is in their life that isn't good may get better. Okay. It gives them optimism, it gives them hope. And they use the word crutch, which I don't like, but that's what people talk about in terms of spirituality. So the positive aspect of that is this, and I'll give you a little bit of feedback. When you meditate, when you do meditation, for example, when you do meditation and you get into deep meditation, do you know what happens? The amygdala in your brain shuts down. And the amygdala is what gives you your ego. Okay? If you shut down the ego, you shut down yourself, you get closer to, what maybe non-ego is like, okay? Not self so much. And that's called the default mode network. And so when you meditate, you shut down the amygdala, but guess what happens? You get dopamine release up to 65% when you meditate. When you get dopamine release, dopamine is the most important neurotransmitter in the brain. Now, what people don't get correct is when I keep talking about dopamine, 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 they keep saying, what do you say dopamine? Why do you say dopamine? What about all the other neurotransmitters? Well, I say, of course, there's other transmitters. And that's why I came up with something called the brain reward cascade, where serotonin interacts from the hypothalamus, right? All the way, all the way, uh, affecting the endorphins, affecting GABA, substantia nigra, affecting glutamine and the PTA, cause dopamine release. You need 7 neurotransmitters and God knows how many key second messengers, right? To cause dopamine release at the nucleus accumbens to make you feel good, or to give you enhanced cognition, or to reduce pain sensitivity. The whole, I'm having a new paper that's coming out. It's going to come out in Gene Proteins Disease, where we talk about dopamine as being the commander of the new connectome. You know what I'm saying? And the idea is that this meditation gives people a good feeling. The idea of linking to spirituality gives them positive dopamine function. Okay. And it's known in the world of addiction that people that get into spirituality, and it doesn't mean to say you have to believe in God. It just means that the idea that you feel there's something bigger than you and you're gonna be okay, the optimism that you get affects your neurotransmitter system, affects dopamine, you feel better, and you have less relapse. And that has been proven. I did studies on it, others have the studies on it. So spirituality or neuroconnectome is a very important thing, an aspect that people need, especially in the area of mental illness or reward deficiency syndrome, which I think is above all mental illness. Does that make sense? Huh?
Yeah.
Yeah. So a little bit more. I'm going to give you a little bit more. There's something called genospirituality. And genospirituality was first developed uh, by Bruce Lawson and in the Journal of Medical Hypothesis. And that was talking about the fact, now this is wild, that was talking about the fact is that can we in the future provide people with genes that load on to the idea of temperament and belief in some form of spiritual being or some form of spirituality event because he felt that if he could do that, then you could maybe help a lot of people in terms of getting better, getting out of this idea that there was no hope and the idea that everything in life is terrible and I'm being suppressed, I'm being oppressed, which by the way, it's true in many situations. I'm not, and by the way, uh, America for the first time is feeling the surge of oppression. So with Trump, and I don't want to get political, but the point is that the lack of optimism, okay, and the enhanced pessimism needs to be counted. And the idea of geno spirituality was an idea is can you actually execute and cure uh, the genes that prevent you from reaching geno spirituality? And I could talk about that also if you want, but that's where we're moving into. So we're moving into the idea of curing the RNA to affect certain proteins that are involved in making you feel better and making you more optimistic and bringing about a better feeling that may lead to some form of spirituality. Does that? Well, you know, Iris, everybody talks about neuroplasticity. All neuroplasticity really means is just any kind of change, potentially, hopefully, in a positive direction. Okay. So the question is this: what can you do, first of all, to use the word prediction at a very young age for the concept of reward deficiency syndrome? Okay. Is there a way, first of all, that you could look at genes, and I'm talking about DNA, okay, that can help predict whether you got reward deficiency syndrome? Number one, okay? That is a very important question, okay? Because the sooner you could identify the fact that people have, I call it, quotes, a hypodopaminergia, which simply just means low dopamine function, the better off you are. The question is, can you do it commercially? Can you do it successfully? Can you do it accurately? And can it be cost effective? And that people could afford. Now, let me, this is a very powerful, important question because I'm fighting with the whole field about this, okay? Now, the so-called geniuses of the genetic world that believe that the more you find, the more genes you have, the better off you with a diagnosis because you may lose a gene here and there, and oh my God, you can't predict it, you know, and that's not true. And I'm going to tell you why. Okay, because the importance, first of all, is can we predict reward deficiency syndrome early on? I'll get to the neuroplasticity in a little bit, but let's just focus on the idea of diagnosing reward deficiency syndrome. Now, we just did a study, Iris, that is not published yet. We're submitting it this weekend, okay, to Nature Genetics, okay? And the study talks about this. When we go into all the large existing database and you go into genetic wide association studies, and you do what we do, we're the first people to ever do a meta-analysis on meta-analyses for GYs, okay? You understand? We found that when you ask the question, could the Gauss test, which is, by the way, coming out in your journal, okay?
Yeah.
If we use the Gauss test, can we predict with only 5 genes, not thousands, all mental illness? Okay? Now, we did the test. We got it ready. We found unbelievable results. Should I tell you why? Here's why. Because we found, now this is going to change the entire concept of how you could go and diagnose mental illness. Okay? Because people are talking about thousands of genes. Okay. So we asked that question to this big data set. And by the way, the number of participants in this study, based on the GWAS meta-analysis, is only 70 million people. Okay? So the study participants is 70 million people. Okay? Huge. All right? Now, here's the thing. You know what we found? We found we started out with 700 genes that were involved, okay, in mental illness, okay, and then we looked at these genes and we filtered them down because they have to be in what we call a network. Otherwise, it doesn't count. These genes got to be connected, okay, to give you the idea of mental illness. We ended up with 29 genes. And the 29 genes, this is very powerful. 5 genes within the 29 genes. I'm going to tell you what they were. The dopamine D2 receptor, the dopamine 4 receptor, the opioid mu receptor, okay? The catechol-methyltransferase, and the serotonin transporter, 5 genes. And when we take those 5 genes out of the 29, you know what happens? Only 15 stay connected. When you have those 15 genes, you know what you can no longer identify psychiatry. You can identify migraine headache. That's it. So the 5 genes are so necessary. And you know what the predictive p-value, you know p-values, right? The predictive p-value, guess what? For the D2, to predict all mental illness, to predict reward deficiency syndrome, predict dopamine dysregulation, pre-addiction is 10 to the minus 17. And the D4 10 to the minus 16. The opioid receptor 10 to the minus 16. The CRMT 10 to the minus 16, and the serotonin transporter, by the way, is 10 to the minus 17. So with 5 genes, we can predict all mental illness. We don't need 1,000. That's the first thing. It's very important. And we're submitting the paper to Nature Genetics this weekend. Okay? Now I'm going to stop. Neuroplasticity means is a change. Okay? And it can be a change in the negative direction too, not just positive, right? But the positive aspects would be, what could you do, okay, if you were able to manipulate the DNA in some way to affect the RNA, to affect the proteins? In other words, how could you affect D2 receptors? How could you affect D4 receptors? How could you affect opioid receptors? How could you affect the enzyme that destroys dopamine in the synapse, CRMT? And how could you affect the transporter system to reabsorb, say, serotonin? Okay? Well, we could do it. We could do it. We don't need heavy drugs to do it. Now, I don't know if you know about my work. It's called KB220, which is a neuroadaptive complex containing precursor amino acids, other herbs that basically could affect every part of what we call the reward cascade. Now, what we have done in the past, okay, we have used the Gauss test, which is the DNA, okay, to determine the proteins. And if you have, for example, a low D2 receptor gene, okay, we could increase the D2 receptors by increasing the precursors involved in the synthesis of dopamine You know, in other words, what I'm trying to say is we could use the gauze to give us a customized way of balancing the dopamine in the brain. If it's too high, we can figure out a way to lower it, which I've done, and too low to bring it up to balance it. And I got pictures and studies to prove that I got neuroplasticity by doing that, by changes. I got pictures, imaging, showing what I was able to do. And abstinent heroin addicts, by the way, in China from Beijing. Okay. And we got that study published. Okay. So my concept is that you could take the DNA of the five genes, and when you know that, you can use the same way of bringing about, I call it a pro dopamine regulation. Okay. And by using this, we could bring about change in the right direction, which I proved with neuroimaging for neuroplasticity and people that have reward deficiency syndrome. So it's not just saying you got, how could you do it? We could do it. We could do it. Now, we have to remember that we're looking at DNA, but there's something more, just as important, the environment. And the environment is epigenetics. And the epigenetics is there as well. I published on methylation of the D2 gene and blah, blah, blah. And we're still trying to figure out how to change the epigenetics, which is the environment. Because Iris, I don't know how much you know about this, but if you got a negative uh, event, let's say an abuse in the family, okay, you get methylation onto genes that make you feel good, like the dopamine genes or the serotonin genes. You know what I mean? And that's no good. That's just the genome. That's methylation on the histones, which are sugar molecules, right? Methylation, bang, stop the expression. If it's positive, it's love, love your pups. What do you get? Get acetylation that increases expression. So we got to find a way to increase acetylation, more positiveness. And that's where spirituality comes in. The idea of more positive thinking, okay? And you get more positive acetylation on the histones related to genes that control well-being, okay? That's the whole point of neuroplasticity of reward deficiency syndrome. That's how it works. So my view is, now listen to this. You do a DNA test, you're going to laugh, at birth. And then you find out whether or not even the baby is set up to have RDS. I know. Then what you could do, even at a young age, and it doesn't stunt growth. We don't have all the data yet, but you can actually put in these amino acid precursors that basically safe as all hell. You could end up even if you don't want to start as a baby, you can start when before they reach puberty. You know what I mean? And you put them on a nutraceuticals that will that could be that can be linked to your DNA, which is customized. Okay, which by the way I did in older people, and then you could do RNA profiling, Iris, and you can start measuring. It's simple. You just take the blood and separate the lymphocytes, and you can measure whether or not you're affecting the protein to make it better so that you can understand you have a way of measuring what you're doing. And my concept is that as a kid grows, instead of growing up with all the negativity and the brain is not functioning correct, and even though you got to be, I don't know how old you are, but supposedly 26 you get myelination of everything in the brain, but before that you don't have it all. So some of the decisions are not great, and but the fact is that if you can start that out early, you could prevent ADHD and PTSD and a lot of stuff. And that's what we call smart neuroplasticity. Does that make sense? The answer to that question is to understand this. Science is not one box is neuroscience. That another box is physics. Another box is mathematics. Another box, is psychology or psychiatry. It, good science is the collaboration of all these things coming together. Because if you're just a neuroscientist, then you don't understand what's going on in the world of physics. Okay. And if you're a physicist, there's a lot of things going on in life that the neuroscientist knows, but you don't know. Same thing with mathematics. Okay. You cannot have good science without collaboration. And if you want to talk about a specific collaboration like spirituality, okay, when I wrote one of my papers, uh, I interviewed. Did you ever hear of the evangelist guy in America called Billy Graham? Does Billy Graham mean anything to you? Probably not. Does it? No. Billy Graham was a guy who went all around the country in America and the world talking about God and spirituality. So when I wrote a, one of my papers involving spirituality, this is a recent one, by the way, I interviewed his grand nephew. His name is Ben Graham, okay? And he runs the church called the Music Church of Nashville, Tennessee, okay? And he believes in music and spirituality, okay? I interviewed him and I put him on the paper because we were talking about the importance of spirituality. So there you have it. I collaborated with a preacher to make my paper better. So absolutely collaboration is the most important thing you could do no matter what science you have. And if you look at my papers, if you go into PubMed, you look at my papers, I never write a paper by myself. Never. Maybe one in my whole life. I write most of the papers. I write most of every paper that I'm on. I write it. But I bring in all these people. I got a team of 50 people that make up we call the reward, the RDS Consortium. 50 people around the world I collaborate with from all different disciplines. And then we come together and we work out papers that we all work on. Not every paper, because I can't put every 50 people, but a lot. So when you look at my papers, you see a long string of people. That's because I collaborate with them, and I lead that team so that we could come up with the best understanding and collaboration, whether it's spirituality or whether it's. I even wrote a paper, by the way, in quantum physics in the brain. That's what I mean. I deal with even physicists, okay, on my papers. So, and mathematicians. So there's that's the way I explain it. Ah, of course. Okay, I'll tell you, I'm going to tell you about my my newest paper. How's that? So, my newest paper is about personality. Now, personality, part of psychology, is part of psychiatry and part of neurology. Okay, and so in fact, I'm working on it today. By the way, I'm working on the draft of the paper. So we uh, looked at what genes constitute the neurological aspects of all personality, whether it's PTSD, ADHD, drug abuse, depression, suicide ideation, blah, 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 blah. Okay. And we found two top genes. Now, there's a total, when we did all our filtering about networks and everything, we got down to 23 genes. Okay. And the number of people were not as big as the other one. This is only 6 million people. Okay. And still pretty good. And what we found was that the two most important genes in terms of neurological aspects of personality is the dopamine D2A1 allele or the ApoE uh, gene. So it's the D2 gene and the ApoE. Now, why? And by the way, this is not the first time that the DRD2A1 allele has scored top. Okay, there's a new study that came out just 2 years ago, about a year and a half ago, using 1.2 million veterans by a guy named Levy from Washington University, found that for depression, Iris, the DRD2 gene was the top gene. Okay, then there was another study uh, from Kimball's lab in Dartmouth, suicide ideation. The top gene was the DRD2A1. And then from Hawthorne's lab, what came out that it was substance abuse. DRD2A1 came out top. Okay. Now, the other side of the coin is the ApoE. And the ApoE is very, very prominent, as you know, in Alzheimer's, okay, for all cognition, and very involved in alcoholism, liver problems, lipid problems, and the ApoE is very involved. So those two genes predict very well